Reluctant Preppers provides educational awareness and commentary only. Opinions expressed do not constitute personalized financial advice. Viewers are encouraged to do their own research and seek qualified personal financial consultation before making investment decisions.
As a responsible person with growing concerns for your privacy and personal liberty, you want to know where we're headed and what you can do about it. We ask the experts what you need to do to take prudent and responsible action to safeguard your family's wealth and well-being, and what basic first steps will help you to be aware and prepared. ReluctantPreppers.com.
Does your family ever get exasperated with you for stockpiling such things as paper towels, bottled water, or toilet tissue? Well, they certainly can't object to you stockpiling money. Silver, the only money recognized by the U.S. Constitution, and your first 10-ounce bar of pure silver can be had at spot price with no premium by going to sdbullion.com/rp. And when you buy it that way, you'll be supporting Reluctant Preppers as well by going to sdbullion.com/rp. Thanks. Hey, Reluctant Preppers. If you haven't heard, we've already started our monthly 1-ounce U.S. Silver Eagle thank you gift to one active Patreon subscriber each month, signed by your host, Dunnigan Kaiser. And you don't want to miss out on that.
Please help us grow by subscribing today at patreon.com/reluctantpreppers.
Welcome back, Reluctant Preppers. We have a returning guest today, but on video for the first time, Dr. Arthur T. Bradley, PhD. He is a NASA scientist by day, and he is the founder of DisasterPreparer.com, the author of numerous books about post-apocalyptic survival. He's an EMP expert, electromagnetic pulse expert. He's here with us on Reluctant Preppers to answer your questions about EMP protection and safety. Dr. Bradley, thank you for joining us once again on Reluctant Preppers.
Thanks for having me.
We've got more viewers' questions than we can possibly field in the time we've got together. So what I'll do is I'll pick and choose from among the list and go as quickly as I can. And then I want to give you a chance at the end to talk about, because we had one of our viewers specifically request that we bring you on this time, mentioning that you have a new whole house EMP protection solution that we'd like to find more out about. So if we can get to that in a little bit, first, if you're willing to take some viewer questions.
Sure. Yeah, go ahead. I'll see if I can answer them.
All right. The first one from Jeff Logue says, what would happen to solar panels in an EMP?
Yeah, I get that question asked a lot. Of course, everybody's worried about their solar generation system. And so what I did to get a firm answer on that is I reached out to a guy named Tom Brennan, who's the, I guess, the founder or president of a company called Solarc. They make EMP protected solar generation systems. And so they've done hands-on real-world testing at full 50 kV per meter and even higher testing of solar panels and solar systems. And his message to me was this: when solar panels were disconnected from everything, in other words, just freestanding, they were not damaged by the radiated wave. However, once they were connected up to the charge controller and the inverter and all the rest of the system, then they were damaged by the impulse. And so the short answer is, if they're packed up in a box somewhere, they're probably fine. But if they're connected and being used, then they're very vulnerable.
So if people, sometimes when people have talked about putting things in a protective Faraday cage or whatever, having a spare cell phone or a spare whatever, anything electronic that could potentially have been damaged in a pulse, it sounds like if people really want to cover their bases, they might have some spare solar panels on the side that they could install after an event if there was one. But it sounds like there's more to it than that, but there's some ones with intrinsic protection built in, it sounds like.
Yeah, so they do make they make and sell those solar, really it's EMP protected systems. And there are some things you could do individually. You could certainly, if you have a system already in place, you could get some ferrites and put ferrites on the power leads, which would help to at least suppress the transients. There's no guarantee that it would make them survive, but it would certainly help. That's a low-cost solution, probably for $50 to $100. You could put a few ferrites on the leads, and that would certainly help some.
We've got another question from Ares Flash, who says, is there a certain topography that will reduce the effects of an EMP, such as a narrow valley or canyon, or on a mountainside of the downstream side of the event?
Yeah, I think the Earth can certainly provide some shielding. And I've read some interesting reports that places close to large bodies of water were more susceptible to field levels would be higher. And also lines that ran certain orientations, let's say north to south along longitudinal lines, would end up coupling in more energy than the latitude lines. There's a lot of theories out there about that sort of thing. I think the short answer is if you were deep in a bunker or down, in a valley somewhere protected by mountains on all sides, you're likely to get a lot lower waves. But it's a difficult thing to predict. I don't think anybody could say with certainty.
This is an interesting one. It sounds like there's a historical reference in here as well. Charles Wilkie asks, they say the energy from an EMP would travel through electric wires and fry anything connected. What are the chances that could then cause homes to catch on fire? During the Carrington event, the telegraph machines caught on fire. Would an EMP start tens of thousands of structure fires?
Yeah, it's a good question. I'm not sure I know the answer definitively. I've heard reports that they think several of the transformers would catch fire, and there are some transformers that are as large as a building, and if those catch fire, you've got quite a mess on your hand. And then of course there's smaller transformers with top holes and things like that, which people are worried about catching fire and bursting and putting hazardous oil and other things on the grounds. I don't know if that energy would be strong enough to get in and start a fire at the house. Because if you think about it, if the energy is very brief in time, right, like the E1 or E2 pulse, it's going to be way too brief to get a delta T fast enough to catch a fire. It's really the E3 pulse, the long duration pulse, which is what the Carrington event had, right, a solar event. And things that last for seconds or minutes have lots of time to heat things up. And in a home, it's certainly possible to bring an E3 pulse into your home, but I don't know if it would be enough energy to catch everything on fire or if you would just end up destroying the various electronics connected to the home.
Mm-hmm. James Kravitzy asks, with the increasing use of smaller electronic devices, which would be more prone to failure following an EMP or CME, tube or solid state equipment? And are LED devices more likely to fail than incandescent lighting?
Yeah, so certainly vacuum tube, there aren't many vacuum tube related products anymore, some old radios maybe, but they were pretty robust to high fields and high conducted energy. Solid state devices are much less, they're much more susceptible, much less robust, right? And so modern processors and controllers are very easy to damage with high voltages and high fields. So that one's pretty easy, and that's why everybody wants, the old vacuum tube radios and things, they feel like they're much more robust. I think that's probably true. In terms of lighting, it's sort of two things work against one another. One is that very small devices have very small traces, and very small traces couple small amounts of energy. And so small devices are really less susceptible than something that's very large. On the other hand, they have very small voltages in them, so they're easy to damage. And so there's sort of this trade, like cell phones, you'd say, the largest conductor is only, 3 millimeters or something. And so it doesn't couple a lot of energy. But on the other hand, what energy does get coupled damages things very easily. So I think there would be some widespread damage where things that were most damaged would be solid state devices, things that had computer chips in them, and things that were least damaged would be things with heavy motors, for example.
Richard Turner asks, the experience of the EMP was discovered to be as a side effect of the largest nuclear above ground tests. I'm not sure about that, but that's what the question asked. This happened just before the agreements to end the above-ground testing of nuclear weapons. The resulting information from the last above-ground experiments on nuclear explosions to create EMP hardening processes. So are you aware of the historical learnings that we got from the above-ground testing that was done regarding EMP protection?
Well, I'm not versed on every single test that was run. Of course, there was a bunch of Starfish Prime type experiments done over the ocean, and there's a famous one. The Starfish Prime was the one that they felt all the way over in Hawaii. I think it was 900 miles away, caused some burglar alarms and other things to become damaged, some garage door openers and things like that. And I think they expected the EMP, but I don't think they expected how strong it was going to be and how far it was going to reach. It was discovered at that time, though, this was in the 60s, very early 60s, that indeed it might be something that could be useful. Now, keep in mind, this was before the modern invention of everybody carrying around cell phones and computers in everybody's home. So I don't know that they knew the extent of its usefulness until, let's say, in the last 30 years.
Ed Pomey asks, what do you need to make a basic gunmetal cabinet function as a Faraday cage? Gun cabinet, sorry. Yeah.
Sure. Yeah. So for my book on EMP preparedness, I tested, I guess about 8 or 10 different ad hoc Faraday cages. Everything from a fire safe to an ammo can, you sort of name it. I didn't test a cabinet like he's talking about, but it's similar to the things I did test. And here's what I found. The metal is plenty thick enough on any of those things. In fact, 2 layers of aluminum foil is plenty thick enough. So it's not how thick it is, it's what really compromises your shielding is the long seams that might be opening into the cage. So a good experiment to demonstrate this is to get a galvanized garbage can, one of the big, 55-gallon drum garbage cans, and put the lid on it and take a measurement of its shielding effectiveness. And you might get 10, 15, 20 dB. And then if you run a piece of conductive tape around the lip of the can, so you seal up that edge all the way around, it might go up to 50 dB. So it's significantly better when you seal up that long sort of thin gap that goes around it. And then just for fun, take a drill and drill, let's say, 1/4-inch holes in the side of the can. And everyone you ask, you'd say, oh, well, if you drill holes all the way around the can, the shielding is going to go way, way down. But in fact, it does not. The shielding does not affect it hardly at all. It might drop a couple dB. And so what you find is it's not the holes that really compromise the can or the Faraday cage. It's the long seams. They act as slot antennas, and they bring in the energy quite efficiently. So if he was going to take a cabinet and make it into a Faraday cage, he would want to tape all of the seams, the long exposed seams that he could on the cabinet, and that would help make it a good Faraday cage.
This next question has to do with the susceptibility of nuclear power plants. George Shea says, will our nuclear power plants be able to shut down automatically during an EMP? And if so, will the backup generators work and the cooling system engage? And then what will happen 7 days later?
Yeah, that's a great question. I had that question myself when I was researching for one of my survivalist books. They go to, in the story, they go to a nuclear plant, and I kind of wanted to do my homework and understand how that worked and what the safety systems were. So I actually interviewed a person from one of the nuclear power plants and spent about, 2 hours on the phone with him asking him exactly those questions, which is what happens if electrical power fails? And his answer was, don't worry, we got you covered. We're ready for an extended duration blackout. And so we started talking about scenarios. And the first one was, well, if power drops out suddenly, what happens? And there's a fail-safe that occurs within 1 second where at least the nuclear process is stopped. Now, it doesn't mean that everything's cool. It actually takes several days for anything in the reactor to cool, but it is able to be kept cool. Even without electricity, they have the ability to pump water through there. Of course, then you'd argue, well, what happens if those generators, which are doing the pumping, fail? And some of the nuclear power plants are actually self-feeding, where the heat that is generated from the nuclear plant operates the turbine, which in turn provides energy for the pumps. And so they sort of self-feed them. They generate their own electricity to keep themselves cool, which is an interesting thing. I thought that was pretty clever.
That's clever.
Yeah, and they have several different stages of backup generators. They have big building-sized backup generators, which, of course, he assured me, they're going to be fine, but, who knows, right? And then there's a national plan in place to bring in portable generators if the backup ones were to fail, or if they were to run low on fuel, they'd have to pipe in fuel. So he had sort of this multi-level of protection. And so I asked him a few questions which were pretty telling. One was, well, what if everything fails? What if the generators start dropping out, or you can't get fuel supply, or whatever it is? What do you do? And his answer was that most of the power plants are near a large body of water for a reason, and that they have mechanisms by which that water would flood essentially the nuclear power plant area to try and put it underwater. Now, we learned from Fukushima that's not fail-safe, right? Because that water came in, but it didn't necessarily prevent the release of radiation. But anyway, he had several layers of protection, and that was sort of the last Hail Mary of it, all of it. One thing that was interesting to note was, even though the nuclear fuel that's in the reactor can be cooled off within a few days, those rods stay hot for essentially years, up to maybe 5 years. And so every so often in that case, every 18 months, they took out the rods that were not as efficient, and they moved them over into a large pool of water. It looked like a giant swimming pool. And those spent rods had to remain there for years, at least a year or two, until they were cool enough where they could be brought out and stored in these big casks, basically these big concrete casks above ground. And they were still very, very hot and very radioactive. So it's a long duration problem to solve. And if you ever had a national blackout that lasted a year, like some people predict, you can imagine the challenges they would be faced with trying to deal with that.
There's a related question, and yes, you may pass on this because it's a different expertise domain, but just saying, if that were to happen, how far should people live away from a plant in the interest of safety?
Yeah, I don't have a firm answer on that. I did do a little reading on that myself, And it looked like that, the biggest danger is that when these gases are released, let's say these spent fuel rods boil off the water, and then those spent fuel rods cause an explosion, right? And the explosion releases radioactive material into the air. And depending on how the wind blows and all of that, you can imagine how far it might travel. But certainly within 30 miles, I think, would be considered serious, and that you should probably get out of that range. Maybe it's further depending on wind patterns and things, but that's, I think, the area would be most affected.
This Eddie Jones asks us, and there's a couple, Granny Fisher had a very similar question, so I'll just lump these together. What would be your major bullet points for the average person to prepare or have covered in the event of an EMP?
Yeah, so an EMP is just one of many threats, right? And so I usually tell people to not focus on the specific threat until they have their general preparedness plan in place. So, we face hurricanes here on the East Coast. Other people face earthquakes or whatever, snowstorms or other kinds of things that they might worry about. And so people need to put in place a good practical disaster preparedness plan, which is why I wrote my handbook to start with, was just try and give people a general approach. Where do you start? What am I worried about? You start by asking that question. What am I worried about? What's it going to do to me, right? And once you know what it's going to do to you, you take some steps to mitigate those impacts, right? Store food, store water, whatever kinds of things you need to do to get prepared. Once you have that general plan in place and you can meet most threats, then you can turn your attention to something more serious like an EMP. And an EMP has a few specific preparations. You have to think about the biggest impact of all would be the loss of the electrical grid. And so you have to think about, how do I function for perhaps months, perhaps longer, without any electricity whatsoever? And that means different things to different people, right? If you have medical conditions that require electricity, maybe to keep something running, that has a different impact on you than if maybe you live in Florida where you could survive without heating. And, everything's a little bit different for each person. But you start assessing those long-term impacts, and certainly the loss of electricity is the first one. And that's just the first of the dominoes, right? You lose communications, and you lose probably emergency services pretty quickly. So you very quickly become fairly self-sufficient one way or the other. And so if you want to be prepared for an EMP, you have to start working towards that goal of being essentially self-sufficient, at least as part of a small group. And there's lots to that. We could talk for hours about that.
And just to remind people that in addition to being an EMP expert, you are at disasterprepare.com, also the author of the handbook for disaster preparedness. You've got several versions of that for families and practical guide and so on. So your advice in those manuals and in those handbooks goes well beyond. It's general in nature. It goes across many different topical areas. We have this one from Stan Farina, who asks, most preppers stress out about radiative EMP energy rather than power line surges. What is the greatest danger and threat?
Yeah, that's a great question. So certainly it is so an EMP is a nuclear device, detonates in the atmosphere, releases a very broad band, and that means very sharp in time, impulse of energy, electromagnetic energy, right? Perturbates the Earth magnetic field, causes a whole bunch of ground currents to flow at the Earth and radiated waves. So everybody likes to focus on the radiated waves, right? These very, very brief in time waves that zap your cell phone or maybe destroy your car controller or something. And a lot of that's made popular by movies and books because it paints a picture of sort of everything stopping working at one time. And in reality, that would not happen. In reality, some things would break, some cell phones would break, some computers would break, maybe some cars would break, but let's say maybe 3-5% of cars might start, becoming defective, not be able to drive them, but not 100%. It's just not as great of a story if only 5%, if only X number of millions of cars are out instead of the whole world. But one thing we know for certain, if an EMP is detonated, it will cause a huge conductive pulse on the power lines, no question about it. And that will cause damage to our electrical grid. And almost certainly it will take down the electrical grid. And how long it will stay down depends on who you're talking to. Many people have predicted, because of those large transformers being damaged, that it could last for many months. And I do think that is the greatest impact, much more so than the radiated effects. Not to say you shouldn't put things in Faraday cages. Yes, you want to protect your radios and other things. But when that surge comes in, let's say down the transmission lines and destroys everything in your house that's plugged in, that's going to have a very serious effect on you because you can't take your generator out of the garage anymore and power your house, right? Or, if power does manage to flicker back on and off every couple of days, you're not able to take advantage of it anymore. And so that conducted energy, I think, would likely have a much more serious impact by taking down the grid and causing widespread damage.
You mentioned just now about that. What is the source of an EMP? Could be a atmospherically exploded nuclear weapon. GT asks, Joel Skousen states that one EMP would only knock out vehicles within a 300-mile radius. Do you concur?
I think that's just somebody's particular analysis. It depends on the strengths of the fields that were generated, and I mean a lot of different factors, the types of vehicles and everything else. The EMP Commission did some testing on vehicles, 50 some odd vehicles, 54 I think it was. And what they really found was that vehicles that were shut off, that were unpowered, they couldn't cause them damage with the limited testing they did. But when the vehicles were powered, they were able to cause some disturbances and damage in them. And so predicting how many would be damaged and for how many miles, I think is beyond anybody's means right now to say.
In general, this is another question from Brian Jenkins. I'll paraphrase it, but cars have become more electronic, but they're necessarily more shielded. Will they be widely unable to operate after an EMP? And you mentioned that perhaps a minority of cars could be affected, but let's press that a little bit farther. Some people are strong advocates of really older cars, like even diesel ones that don't have spark plugs, things that are built prior to electronic ignition back in the old days. So is there a significant advantage to older classic cars as far as not susceptible to an EMP?
I think there would be. I think it's a logical conclusion. Modern cars might have 1,000 microcontrollers in them, and these are all any few of them could fail and the vehicle would not be able to operate properly. And the EMP Commission did say that a good percentage of vehicles would suffer anomalies if an EMP happened. So, your dash lights might go weird and your gauges might act funny. Many vehicles might be able to recover by simply, taking power off them and restarting them. Some of them might recover, some might not. I think older vehicles would suffer less, and so I think it's a reasonable thing for people to think about. But I don't think it's a certainty that just because it's a modern car that it would be damaged.
Now, with our last question here, we're going to go to the future, or the future as we see it from here, and that is, Dick Masters asks, how will the outlined details of Trump's Space Force alter the playing field in satellite-based EMP weapons or any other orbiting weapons platforms?
Yeah, I don't know. I don't know where that's headed exactly. I know that just a couple of months ago, I was in a conference where it was an EMP-related conference, and we were having discussions about that. And I know the experts who were there at a national level, these were retired admirals and other people who have been around in the EMP Commission and so forth. They were very excited to hear about this Space Force. But I don't know exactly. It's been ridiculed a little bit. Some people celebrate it. Some people ridicule it. I'm not sure where it's going yet. And I say that as somebody who works at NASA. I mean, I don't know if NASA will have a role in any way or if it will only be a military type thing. So I don't know yet what it means. And if EMP is in fact would be a focus of it, or laser-based weapons might be, or anti-missile defenses, I'm just not really sure where that goes yet.
One of the embedded sort of subparts of that question, though, maybe bears something that you might have looked at, and that when you've talked about atmospheric exploded nuclear weapons causing an EMP, if something is in Earth orbit, like a satellite orbit, is that at a higher level outside the atmosphere, does that change the game as far as its advantage or effectiveness as an EMP source?
Yeah, I don't think anybody knows for certain. We've only had limited detonations, right? And we know that you have to be above the source layer, so you have to be tens of miles up, right? And you certainly could be 100 miles up and get a nice broad exposure, or even a couple hundred miles up. The question is, if you start getting completely outside the atmosphere, I'm not sure what attenuating effects there would be. So I don't know that anyone knows that answer specifically. If there's a maximum height that gives you the best and most damage, let's say, for example.
I'd like to change our gears here and shift back to Earth and talk about a question that one of our viewers asked. In fact, that's what reminded me, a little poke in the ribs here to give you a call, because we were supposed to circle back about this time anyway, but it got me to do it. A viewer said that you have been planning a Kickstarter campaign for a new whole house EMP protection approach. I know nothing about that, and we'd like to hear. A lot of our viewers would like to hear more about it. So can you give us the lowdown on that?
Sure. Yeah. So people have been writing for years and asking me, is there such a device out there that, like a surge protector that somebody makes, I could attach to my home that might protect it from the conducted energy that would be released from either a solar coronal mass ejection or an EMP? And the answer's always been no, because no company has really wanted to spend the NRE to figure out how to protect from those type of specific
non-recurring engineering for upfront
right,
engineering.
Non-recurring engineering. So it's non-recoverable engineering, essentially costs that are lost, right? You have to spend so much dollars just to develop a product before you can ever start selling. And so the short answer is no, nobody has that product out there. And so I started thinking, well, I'm an electrical engineer, been an electrical engineer for about 30 years. And that's what I do. I design electronics. I thought, well, is this that hard of a problem? And I thought about it a little bit. Actually, I thought about it for several months. And I finally came up with a way I believe would tackle that problem. And by tackle that problem, I mean this. It has to be able to address the very brief E1 pulse, right? Some of that energy is going to couple onto your power lines, and it's certainly going to come in and perhaps do damage. And then there's the more normal pulse, the E2 pulse, which is very similar to like a nearby lightning strike, really. It has to be able to suppress that. Now, actually, most modern surge suppressors could suppress E2. The problem is they may be damaged by E1 before the E2 arrives. And then finally, it has to, whatever device you hook to your house, has to be able to somehow or another protect from this very long duration E3 pulse, which would be very similar to what you saw from a solar event. And that's the part that no one essentially has ever designed a product to do that I'm aware of. And so I thought, all right, can I figure this out? And I think I've come up with a way that you could build essentially a new type of surge protection device, attach it to your home, and it would guard against those three specific types of pulses as they try to get to your house. Now, the logical question is, well, what good does it do me to have, a surge protector if electricity goes out? That's the very first question I get. And I alluded to it a little bit earlier, is there's really a couple of good reasons, besides just protecting your home and not getting all your stuff damaged from every time a lightning goes nearby. But the main reason for these specific threats are two things. One is we don't know how long the power would be out, or if it would be on and off and on and off, for example. And you would absolutely want to take advantage of any periods of time that power came on. Mm-hmm. You would not want to have a house that had all kind of things that were damaged in it that you couldn't even perhaps turn power on to your house without blowing the breaker. And so you'd essentially be dead in the water if your house was in that shape. So you want to have a functioning house in case power is able to be brought back on. And then second is, if you have a functioning house, you can always take a secondary power generation system and attach it to the house, right? So whether you have a solar system or whether you have a generator or whatever it is, you can attach it and start, even if you can't operate the whole house, you can operate small subsystems as you need them, the washer to get your clothes washed, or the stove to cook some food, or the radios to be able to call for help. Whatever it is, you can operate those systems. If you don't have a way of protecting the home's electronics, you're sort of dead in the water to start with. So those are my reasons for even trying to suppress the conductive pulse. And it's an interesting and a challenging electrical problem. I suspect once I release this product, others will come out with one that are similar, but I'm going to try and be the first one to do it.
And where are you at in that process? What stage are you at in that process? Is it still a concept? Is it still on the drawing boards?
Yeah, so what I did to start with is, and this is typically the way I do all my designs, is I studied what everybody else did. And so I acquired, let's say, a dozen different surge protection devices of all different sorts. I got a couple on the table here. I can show you some details. But
cool.
Took them all apart and saw what makes them tick. So I'll show you one just so you get an idea. So this is a particular, see if I can get it up here. Yeah, this is a particular surge protection device. It mounts in the garage next to the breaker panel. And what you see a lot of these little blue parts in here. Yeah. And these, everybody calls these MOVs, but they're metal oxide varistors. They're resistors that change their resistance value based on the voltage on them. Oh, I hear it beeping. Hopefully we're okay. All right. So these MOVs here, or varistors, essentially are what provide the protection in just about every single surge protection you can buy. Okay. So I took apart 12, and they all have exactly the same stuff in them. They have those MOVs, and essentially the difference between the surge protectors is the difference in the quality of the MOVs, how fast and how good they are, how much redundancy they put in their systems, just so how much corners did they scrimp really. And I did a video where I showed two diametrically different ones. The one that I just showed is a pretty good one. Okay. There are some others that you would think, by looking at the packaging, you would think, oh, that's a fantastic product. But when you open it up and you take it apart, you would be shocked by the quality. So the short answer of it is, I studied everything to start with. I wanted to know what's out there. Is anybody being clever? I hate to say it, but no, nobody's being really very clever. Everybody's found a way that works to suppress nearby lightning strikes and load shedding by power companies, and it works great, and it's cheap. They can build them. They can probably build them for about $30 or $40 is my guess. They sell them for $100, $150. And so it's fine. That's how they've solved this problem. And I would say every surge conductor or every surge protector that people would have on their house right now is made up of those MOVs. Unfortunately, the MOVs will not in any way protect against E3. So if you get a long duration pulse, let's say a pulse that lasts 5 seconds, 5 minutes, doesn't matter, it will destroy the surge protector. They're not meant to take energy for more than microseconds. And so those things will burn up. It won't hurt anything. They're meant to fail safe. They'll burn in two. You might see a little smoke, but that's the end of it. But then the rest of that energy will come in the home. And so looking at the existing units, I said, okay, these are not going to solve the problem. So how do I do it? And I started sketching out how the circuits might look. I'm in the process now of running some simulations. I've met with a bunch of different vendors to see how their parts perform, and I'm putting together an initial concept design. So it's still very preliminary. The idea is I have a surge generator. I'm going to start testing these things both versus fast surges and slow surges and see how they perform. Once I'm confident in the prototype that it can pass, let's say, a multi-minute surge, as well as these very fast ones, then I'd have one built up that was a production quality unit, and I'd have to have it sent off to Underwriter Labs for certification. And that's not a cheap process, as I've learned. I didn't realize until recently just how expensive that is, but to take a surge protection device and send it to Underwriter Labs costs $19,000 just to have them run the test one time. If you fail that test, get ready to write the second check because you'll have to go back again. So anyway, it's not cheap. You can figure it's around 20 grand just to get through UL testing, and that's if you know what you're doing when you go in. So anyway, once you get through UL testing, then you're approved for production, and I would go into some production and ship them out to people who had bought them.
Just in a nutshell, why wouldn't the standard circuit breakers in a typical home or fuses in an older home guard against that last major pulse that has so much energy in it? Isn't that exactly what circuit breakers or fuses are meant to protect against?
That's a perfect question. And I asked that same question to myself. I thought, well, we already have breakers, right? Yeah. And the problem with breakers, breakers are wonderful for pulses that get either really high and then they go pretty quick, but they're there long enough to, let's say, for maybe 10 seconds, some level that's long enough for 10 seconds to cause the thermal action in the breaker to cause it to trip, right? It's a little bimetal type thing. So the problem would be this, is that we don't know what level that coronal mass ejection is going to induce on the power lines, nor do we know if it's going to fluctuate in and out and in and out, that kind of thing. So let's say instead of 120 volts nominally at your outlet, you have 175, 180, right? Not 5,000, right? We're not talking about the E2 pulse. We're talking about just a modest increase. Well, 180 is enough to start damaging all kinds of things in your home, but it's not enough to draw enough current to blow the breaker. The breaker, remember, let's say your house has a 200 amp breaker on it. It might nominally only be loaded at 30 amps, maybe, going through the house at a given time. So you got to pull an extra 170, maybe more, maybe 370 amps into your house before that breaker goes. So you may never pull that. You may, in fact, just draw, let's say, an extra 100 amps in the home as you slowly cook everything, but the breaker may never go. So it's an interesting problem. There's probably some cases where you would pop the breaker eventually, but what you'd like to do is to pop that breaker in about, let's say, in the microsecond range. When that pulse starts to climb, you want to pop the breaker immediately, and right now they won't do that.
Just one other viewer asked a question is, what modifications to your home's service entrance or disconnect box would you need to make in order to use the type of device that you're coming up with?
Yeah, so I haven't even mentioned the product's name. It's called EMP Storm. I picked that name only because it captures the essence of what I'm trying to do, EMP and Solar Storm. So EMP Storm is what I call it. And it's going to be a Type 2 surge protection device that mounts inside the garage besides the breaker panel, very similar to any other Type 2 surge protection device. What will be different is really what's on the inside of it and what it's meant to do specifically. Now, there are other types of surge protection devices. People have written me about them. There's something called a Type 1, which is usually attached by the electrical company outside of the home. And maybe one day I'll eventually develop one of those as well. The problem with that is you have to have the electrical company actually shut off power to the home and then put that in and then bring back on the power. And that's a bit of a hassle for many people to do. So I opted to go with one that attached to the breaker panel.
I see. Will it go in the place of where the main breaker is and it'll function to divert the power through, kind of a little pass-out loop?
It'll actually probably not go in the box itself because the boxes are unique. GE has their own type. Everybody has their own boxes, and you'd have to get different designs. So it will mount on the wall next to the breaker, and it will wire into essentially the output side of the main breaker.
I see. Okay. Makes sense. And you meant the viewer who asked that we have you on mentioned a Kickstarter campaign. Is that the right terminology, or what have you got going?
Well, so I looked at Kickstarter because everybody says that's a great way to raise some seed funding to get things done. So I put together what I thought was a beautiful Kickstarter page. You can go to empstorm.com and see it. It's got a lot of information about the product and about the schedule and costs and all that stuff. And what I found out is that Kickstarter actually will not allow you to give away or to promise to give away final products of something that's not yet developed.
Nah.
So you have to have a fully functioning, demonstratable prototype that looks like the real product before you can promise to do that. And of course, the only reason people want to support it is because they want one, right? And I get that. And so I thought, well, I have enough supporters. I'll just raise the seed money myself, and I'll take pre-orders for these units. And so I've started taking pre-orders for these EMP storms, and I'm going to use that money essentially to do the design, buy the components, and get the certification testing.
And if people want to find out more about that process, how do they get a hold of you?
Yeah, they can just go to empstorm.com. There's a whole bunch of information there, as well as a link on the side. They can send me emails if they want to ask me questions.
One more question about the product approach that you're taking, and that is there's all different size houses. With some have 100 amps, some have 200 amp service, whatever. What are you thinking? Are you looking at a family of products for different size jobs?
Well, I think what most surge protection devices do is they design for sort of the worst possible case, and that's what I'm going to do as well. So the maximum residential power is essentially what it's designed for. If you went to, let's say, a skyscraper and you had, maybe 1 million amps flowing around the building or something, this isn't the type of product for this. This is for a house or a very small business. That's what these are really for, and they would meet the needs of any of those.
So EMPstorm, all one word, .com?
EMPstorm, all one word, .com.
All right. Dr. Bradley, in addition to any of the questions that I have asked you, is there anything else that you'd like to leave with our viewers about EMP protection, disaster preparedness, or particularly your EMP storm project?
Yeah, well, I'll just say a couple of things. So I mentioned earlier that, disaster preparedness starts with coming up with a plan. So my message to everybody always is start thinking about what that plan is, and don't throw your money at things randomly and just sort of acquire little piece parts of stuff. I see that a lot. Instead, think about what your real plan is, and have you thought about how you're going to have food and how you're going to have water and how you're going to stay warm? Get the basics covered. The EMP storm is just one layer of protection. It's meant to guard against the conducted pulse from these two real threats. But put together a broader plan and think about all of your family's needs. That would be my takeaway message to everybody.
We've been speaking with Dr. Arthur T. Bradley, PhD. He's a NASA scientist. He's an EMP expert. He's an author. And he's been here with us on Reluctant Preppers to answer your questions and to talk about his new project, empstorm.com, Whole House Protection. Dr. Bradley, thank you for joining us on Reluctant Preppers.
Yeah, thanks for having me.